Good day, sir. Today we are going to present on a topic for Fourier transform, and subtopic that we choose for another application is optics. And this is our group members. My name is Ridzuan Hakimi bin Muhamad Jafri, and others is Syazwan Syafiq bin Sahafaruddin, and the one is Aizat Amir bin Muhammad Maidin. So for introduction of Fourier transform, the Fourier transform is a tool that breaks a waveform to function or signal into an alternate representation characterized by sine and cosines. It shows that any waveform can be written as the sum of sinusoidal functions. And virtually everything in the world can be described via a waveform that is a function of time, space, and some other variable. And basically, it can be said that Fourier transform as decompose a waveform, basically any real waveform into sinusoids. And about the Fourier optics is a linear optical system that can be evaluated using Fourier optics. And Fourier optics is a powerful tool allowing the estimation of a visible range imaging system to transfer the spatial frequency components of an object. And then I will pass the next for transform application to my friend.
My name is Aizat Amir bin Muhammad Maidin. Today I will present about task 1. Fourier transform in electrical circuit application. For the first, generalize the pencil technique to non-periodic function. Therefore, we apply Fourier transform to circuit which non-sinusoidal excitation in exactly the same way we apply pencil technique to circuit with sinusoidal excitation. You can see this formula we use. Where V omega and current omega are the Fourier transform of the voltage and current Z omega are independent. Next slide please. Is a light diffraction interference and Young experiment. For the light is an electromagnetic wave. This is the same type of wave that the sun hit the earth, except same type of wave that is used by radios, television, or your personal cell phone to send information. Light wave of all type travel at speed c 300,000 speed. The frequency f and wavelength of light satisfy the following equation. This is example of the picture. As you can see, it is a waveform, and you can see on the right mismatch. Okay, this formula. Next slide. This signal processing filtering. For the first, the Fourier transform is intensively used in the field of signal processing. Number 2, apply a low frequency filter. We can eliminate the horn. And the third is the act of processing a signal to obtain more useful information or to make the signal more useful. And the last, use signal processing and Fourier transform to filter out this undesirable noise. As you can see for the left picture, frequency domain view of LTI system. And that you can see input signal, LTI system, and then output signal. For the right, time domain view of LTI system. just same, but the output signal is different for the other picture. Okay, next slide. Okay, this is a step to calculate the Fourier transform. First step is convert T domain to omega. Okay, for the second, we apply circuit analysis to find the unknown response, such as Kirchhoff's voltage law, Kirchhoff's current law, mesh, model, superposition, or Norton. Take from Fourier transform of excitation. Okay, for the last, convert back omega domain to T domain using inverse Fourier transform. Next. Okay, this is a table of Fourier transform. For the right, this is a Fourier transform. For the left, Fourier transform FT. Next. Also, this is a table adjacent. Okay, next. Okay, I will pass to my friend for this slide.
Okay. Assalamualaikum to sir and my friend. So today I will explain for the task 2, which we are given a task to explain the application of Fourier transform and its calculation example in other field. So we choose face recognition as our main topic, which is under optics. Next. Fourier transform is just one of many different face recognition methods that have been developed over the last 25 years. Comparing to the machine learning approach, Fourier transforms is a very simple and fast algorithm. It attracts frequency features of a face rather than analyzing the image pattern using a convolutional network. The main idea is to find most variant frequency in the image database and identify the faces by matching this frequency. Yes. So I will explain the methodology that have been used to do face recognition. There are three main parts. The first one is localize the central line and vertical central line. The central line intersects the face vertically into two symmetrical parts. The system seeks the position of the gray level higher on the axis of the eyes. The maximum curve corresponds to the central line because it corresponds to the region that contains the maximum amount of skin, which you can see the image have been shown. The red line is in the middle to detect the central line and the vertical central line. Next. The second methodology is localize the axis of the nostrils and the mouth. This methodology is the axis is the line that contains less than pixel of the skin located below the axis of eyes. It has precise localization, then took the area around the nostrils, below of the eyes and around the central line. The maximum of the curve, which is vertical projection and correspond to the axis nostril, which you can see the picture have been shown that the red line detecting the face and the nose central. Next. And the last one is geometrical model. After the system recognizes the eyes and the mouth, the geometric model is extracted to the features of the image. This is the last method of face recognition. Next. Sorry, this is the last method, which is farming and face scaling. I forget the last step. So this is the last step. After localize each local objects of the face, The system will try to frame all the characteristics in a single rectangle, and they will resize the image into specific size linear interpolation. This method to reduce copulation time. Copulation time. So this is the last step, which is that have been used to do the face recognition. Next. So I will explain the Fourier transform block diagram that have been used in the face recognition. The first one is image or video frame, then face detection, then pre-processing stage, then feature extraction, then non-valid face, valid face valid display, and the last one is implementation on Raspberry Pi model. Next. Next. So, for the Fourier transform mathematical equation that have been used in the face recognition is Fourier transform image is the image in the frequency domain. Is as in this field, every point represents a frequency content in the image space of square image of size m times n. The formula of Fourier transform means that an image of size n times n can be decomposed into frequencies of various wavelength j in the direction of u or v. U corresponds to the horizontal directions while v corresponds to the vertical direction. X and Y are the measurement along U and V. As you can see, this is the formula that have been used to calculate and perform in the face recognition. Next. So I will explain about the application in other field. Next. Next. So there are three applications that we are going to present, which is the first one is the fractional Fourier transform in automotive. The fractional Fourier transform FRFT can be viewed as the generalization of the transform with the order parameter. By exploiting the potential of an additional degree of freedom, it is impossible to give a more general formulation of the problem or to improve the methods. By optimizing the order parameter, thanks to the new result concerning FRFTS, such as rotation in the time frequency domain and the relationship between the transform to the Wigner distribution, interest in the tool has increased over the past 2 decades. The transform has found application in optics, signal, and image processing quantum mechanics. So the second application is classification of medical image. Selected methods of image processing have been applied to expert systems supporting the processing of identifying medical image. Fourier transform is a well-known tool for many applications in the processing of image in many of science and technology, also in medicine. In this case, the image processing consists in spatial frequency analysis of Fourier transform of medical image. Skin lesions are studied on the base of their image, and it seems that Fourier transform is the right tool for such requests. The distribution of selected colors in Fourier transform image are studied. So the last one is financial economics. The Fourier transform is an important tool in the financial economics. It delivers real-time pricing while allowing for a realistic structure of assets and returns. Fourier transform is also rather abstract, therefore of putting too many pra- practitioners. Analysis is often used in mutual fund management by decommunication called the Fourier transform. So there are three applications that we elaborate just now. The first one is FRFT, which fractional Fourier transform in automotive. The second one is classification of medical image, and the last one is financial economics. Next. So this is the second one that I've been explained, the classification of medical image. Next. And this is the last one that I've been explained just now about the financial economics. So that's all from me. I will pass to my friend.
So, in conclusion for our topic, the Fourier transform give us a unique way of viewing any function as the sum of sinusoid. This topic essential for us to understand some very useful concept in electrical engineering. The Fourier transform is used in a wide range of application in image processing such as face recognition. Fourier optics is a powerful tool allowing the estimation of a visible range imaging system to transfer the spatial frequency components of an object. And that all of our presentation from us. We hope we give enough information about the topic of Fourier transform. And thank you sir, for your time.